Well, thank you for coming along to this event. My name is Gwilliam. I'm going to be bobbing around, making sure everyone's on time and everything runs nice and smooth. Just before we start, there's a couple of housekeeping bits. Fire alarms, there's no planned fire alarms today. If there is any fire alarms that go off, if you just make your way out to the desk, the IBM staff will lead us out. Just follow me, I'll be the first one out. Smoking, no smoking within the building or vaping. If you want to smoke or vape, you have to go down into reception and outside. Mobile phones, if you could just switch them to silent, please, whilst the speakers are speaking, so we don't have any interruptions. Toilets, there are toilets out at the back of the room, to the left and to the right. And coffee, there are 4 different areas around the floor, and IBM are quite happy for you to go and have a look around and have a look at all the bits that are available for you to explore what they're doing here. So coffee and tea are available at breaks, and lunch will be at 12:30. Everybody happy? Cool. Right, I'm going to hand over to Jorge, and he will give you the intro.
Thank you, Richard. So my name is Jorge Gallardo. I'm the country manager for Habber Tec UK. And thank you all for joining us today. So it's going to be a great, innovative event and inspiring with the latest developments in AI and quantum technologies. So we put this together thanks to IBM. So we partners with IBM. We've been in the business for over 30 years, almost 30 years. Please enjoy the facilities. IBM has got this great innovation center here on the 5th floor. Obviously, we're putting this together, AI and quantum. They've got like a quantum System 1 here in the room. Please do go and have a look. It's super interesting. And then you can have a go and play with all the IBM toys as well. So you got the Ferrari simulator here at the back. So doing breaks, you're more than welcome to have a go at the with the simulator. So Daniel, our solutions architect, is up there actually on the leaderboard with Lewis Hamilton and Leclerc, something like that. So he's got a couple of he's had a couple of laps. But yeah, exciting event covering the a lot of the newest technologies from AI to quantum. Great speakers. And yes, it's gonna be. I really hope you enjoy it. So this is top. Tyler. Okay, now. Right. So you will see. This is gonna be a little introduction of who we are. Habber Tec, so consultancy in technology. We've been there for almost 30 years, as I said before. And you might have noticed that in an event about artificial intelligence and quantum computing, I've chosen to present with a comic. And it's not an accident. It's while AI is the core of productivity, and quantum is, the core of determines what we create. Only the creativity can actually determine what we do with all of that. So I think we need to think outside the box, and that's what we need to use creativity, which is going to be enhancing the future on AI and quantum. So So at Habber Tec, we started as a small startup tech in Madrid, 1997. That's where I come from, although I was born in Barcelona. I'm a Barcelona supporter, but regardless. My colleagues here, they also come from Madrid. We become one of the industry leading AI platforms, automated processes that we used to teach. Our aim is to implement business and services in the market. We've been leaders in the world of business automation, where winning awards in at the IBM Think in Boston last year as business automation leaders, and that's what we would like to think that we're actually driving the forces with the in the world of AI. So I just like to say that we aspire the best version of ourselves by offering the best versions of ourselves. So creativity is key to enhance the AI. Having said that, we're going to go ahead with the first session. So my colleagues from Habber Tec, Daniel Expósito and Ricardo Arguello, who's our general manager, is going to be taking us from some of the solutions that we do. So go ahead. Thank you.
Everybody, thank you very much. Thank you very much for attending this event today. My name is Ricardo Arguello, as Jorge mentioned. I'm the managing director of Habber Tec. We are a company with almost 30 years in the market, but we have been only present in the United Kingdom market for 18 months. So we are especially excited to be here today with you. We see Habber Tec, we see ourselves as a technology boutique, what means that we don't try to do everything, but we aim to be the best at what we do. So we are highly specialized, basically in business automation and artificial intelligence. In 2011, we became part of the IBM ecosystem, and today IBM is our most important technology partner across the different countries where we operate. So thank you very much, IBM, for allowing us to be here today in your role. And honestly, I see this relationship as a real success story all these years. And we can clearly see that success at least in two areas. First, in those sense of transformation initiatives delivered together in some of the leader companies in Europe, Latin America, and Africa, where we are, but also in our ability to innovate together. We have been among the first business partners to implement cutting-edge IBM technologies such as Watson in 2014, as well as hybrid cloud implementation of Cloud Pak for Data, Cloud Pak for Business Automation. And of course, our research and development team is already exploring the real potential of quantum with all of these technologies to transform our customer business. So before I go to the presentation, some of you might be wondering why we have brought together two technologies like quantum and artificial intelligence that might seem very different at the first glance. Well, the first thing they have in common is innovation. Okay, I think all we agree already that the explosion of generative AI is already a reality. It's transforming the way we work, it's transforming the business models. In fact, within the companies that don't adopt this technology are simply left behind. We believe that in a few years, quantum computing will have the same impact in most of the industries. Okay, but we also believe that these two technologies are connected because both work very well with probabilistic systems. Deterministic models will continue to exist in very stable or highly regulated business processes, but generative AI is driving a major shift in probabilistic or stochastic processes. Okay, so this means moving for getting always the same answer to getting the most probable answer. And this is a characteristic in the business. It is a characteristic of the business processes that we will all of us will need to learn how to manage. That's why Dan is here today. Quantum computing is particularly powerful when working with probabilistic approaches and with the huge the huge number of variables that these models can handle. So I am thinking about areas such as investment valuation, risk management, advanced encryption, energy optimization. So this kind of business situation or topics that probably will be discussed during today's session. And now I would like to hand over to Daniel Expósito, who will talk in more detail about the coexistence of these probabilistic and deterministic technologies in what we call both business orchestration and automation technologies. So thank you very much, Dani.
Thank you, Ricardo. Well, today my mission is to show you how we are actually implementing AI agents inside business processes. This is because of our background. We are really strong in business automation, and this is a concept both that emerged last year in a Gartner quadrant that merged both technologies of automation and agentic AI, because at the end we think that it pursues the same objectives. So for that, I will do it as I will show this presentation like this technique on cinema. Do you know the flash forward technique? That is, you first present the final state of the movie, and then you go backwards to show how did we reach that state. So we have created on that final state an analogy that we are really creative. So we thought that a boat could be something like this. So what we try to represent here is a story of how the companies with which we work with, banking, universities, energy industry, what we want to provide is a model to be able to talk with them about what's the current status of AI and business automation, and what we think that is the most important challenges that you have to go for in order to be able to reach that top layer of AI. So we have real lovers of navigation. Ricardo loves sailing. Jorge used to have a boat. Frank loves sailing. I know that Andy Stanford Clark created a boat that went from UK to the USA just with sensors. So I hope that the room is full of sailing lovers. And what we have here is on your left, we have the main sail. That is the sail that usually provides stability and the robustness in the paths. And on the right side, we have the head sail or the Genoa. That is the sail that provides that extra speed. And the analogy that we have built here is that we are currently navigating a complex sea, a complex ocean with huge waves. We are navigating with strong tides. And the idea is that our boats, our companies, have to be able to navigate at the required speed. So first, what we think is that we have to understand our companies from the process perspective. This is the main sail. And for that purpose, we need to discover first our processes. There is already existing technology for that. We have in IBM, for example, BlueWorks Live. Then once we have correctly mapped our processes, we can start digitalizing them. So what does it mean to have digitalized a process? Is that it's not only in our mind or in a paper or in a set of Excel files that we have encountered in many occasions.
is to have it in correct software that was built for that purpose, such as business process management engines. We have in IBM business automation workflow, where we are really strong. And then once we have all of that digitalized, we can start thinking on automation. Historically or traditionally, we have been working with traditional automation like RPA, robotic process automation, okay? Rule engines that allow us to model complex rules and then reflect what the logic in the business is. And the last layer that we think that is really important to look at it from the process perspective is agentic AI. So we want to implement the agents actually in real processes. We don't want siloed agents on different processes that each one uses with their own logic without giving care to the input and knowing what happens with the output. So from the process perspective, it's really important to understand where are we putting our agents. And then from the data perspective, you will know that, of course, if we want to reach AI, we have first, this is simple, but we need to have data availability. Right now, not just structured data, but non-structured data. We need to transform that into information. We have powerful tools here in IBM, Watson X Data, for example. And with that information, we can start to thinking in a data-driven way. So we can build our KPIs and create our agents thinking on how can we improve this. So finally, if we reach the final part of the sale, AI has to be constructed on relevant information for our business. So this means that our agents rely on consistent context that is curated, that comes from sources that are both internal and external. And then those agents want to leverage and improve those KPIs. So this is the final state. And these are the two perspectives that we usually talk with our clients to be able to set where are they in their processes, how is their data, so that we can start building AI. So how did we reach this final state? So 4 years ago, we were just playing around. We remember that on October 2022, we had a research and development team, and we were working with LangChain, a first release that is a really used tool. And we were proposing a fix to Harrison Chase, that is the CEO of LangChain and knows of the figures of AI. And we started to think, okay, where is this going? We see that this framework provides a way to structure inputs to the LLM, then another way to provide structured outputs. But at the end, what we are trying to do is try to act like a specific role in order to complete a specific task. That is not other thing that the same goal that business automation is pursuing. So we started to think, okay, this was us 4 years ago. We started to think, what do we have to do to try to implement this technology? Or what was our process to implement that technology into our business automation clients? So first, we started by understanding the principles. So those are really simple, but well, all we know that agentic AI is LLM-based. It's basically a loop where you use an LLM to reach some conclusions, use a set of tools that you have created programmatically to interact with the world. And then we have to provide a consistent context to be able to take correct decisions with that agent. And in the other branch, we have business automation that is process-oriented. So we want to reduce the mess that actually is created when we start our new operations. Then the goal is to reduce manual work, and mainly it is deterministic. So, well, it seems quite similar, but agentic is not that deterministic, it's probabilistic. But if they pursue the same objectives, at the end we thought, okay, we are really knowledgeable about the patterns that you use to implement good business automation. You need to have reviewable processes, you need to have rule engines in the middle. So why don't we apply that also to agentic? And this is what made us reach that point of thinking, okay, agents have to live in our processes. And Gartner last year created that concept that, well, I think that we were first. So, okay, then once we have all the principles understood, we think we need to connect those points. We need to understand that agents want to automate roles, specific business roles, whilst the business automation usually wants to automate first tasks and then full processes. So we started to map those connections, and then we started on thinking lots of combinations. We can put our agents inside processes. We can make our agents use tools to call new processes and instance them. We can use agents to analyze, for example, what has happened in a process instance, to understand what were the outputs, provide a summary. We can create lots of use cases around this combination of agentic with business automation. And at the end, we think that this is really important because technical people normally has the problem that they understand really well the technology, but they cannot talk with the business world and they cannot reach real solutions. So we build this simplification. This is like about. So we build this just to be able to talk with our internal team, to try to build a common mental model and to work with our clients in a way that everyone understands it. And then reach, of course, the deeper levels that is needed to implement real solutions. So yeah, this is how we reach this. In conclusion, what have derived from all this research and this process is that we can have two levels of win. We can provide our teams licenses of ChatGPT, Gemini, Anthropic, Claude, but is this a real win? Well, imagine that each person is producing some work in their own way. So we have as many processes running as persons using those agents. So in data, there is a concept that is data silos that is related with when you cannot access your information because it's really segregated and you cannot extract value from that information, you have a lot of siloing. And we talk here about process siloing. Imagine that, okay, with ChatGPT, we can increase our productivity, but what if we are accelerating also bad things? There's no one controlling correct context management. There is no one controlling how the input is provided that is really relevant for the output. So this is something that we have to take care of. And the big win for us is not having those separated licenses. Of course, I use it and it's really powerful, but you have to know how to use it. And when you use it in critical business processes, this can be a huge risk. So the big win would be, let's embed our agents into our current business processes, all governed, all the agents that we have are cataloged, are well documented. We apply business process management patterns to it. And this is what I will showcase right next to this. So are agents a risk or an opportunity? In summary, they are an opportunity, of course. They can accelerate analysis. They can give us recommendations. They can, let's say, make us broader, no? But at the same time, as we have talked, we are facing the risk of creating processes that are outside of our control. I remember this advert of Pirelli that said something like speed without control is a problem, no? So this is kind of the phrase that represents the risk with agents on real business processes. And our approach is not going agentic, is using those agents inside real business processes. Those processes have to be well discovered. Those processes need to put the correct automation in order because we don't want, for example, an agent to be taking decisions on a deterministic business rule. For that, we have another kind of technology. So this is exactly what I'm going to show you. So if you want to go to this web page, we have created a landing page where you can see a summary of this session. And one moment, Tyler. No. And what we have here is a representation of a business process that almost everyone will be aware of. That is that of a loan approval request. Okay, so imagine that you are a person that is requesting some credit, some financing, and this is a process that no one that is, let's say, a little bit intelligent would put an agent to analyze it. I wouldn't rely on an agent providing me the decision of approving my loan or not. No, so we are going to show you how, in a hypothetical case, we could implement an agent in a business process. So let's start with the loan application without AI. So we've got here, this is BPMN, okay, business process modeling notation. That is the common language used for BPM engines. And this is a workflow diagram. We would have a person requesting financing, okay? A system, for example, right now, machine learning models are used to evaluate that application information. And then an underwriter have to confirm that decision. If everything is fine, another person will prepare the loan offer and just sending back the loan decision. So what we are going to see is how can we put in this step an agent that extracts more information, more qualitative information that normally is not included in those machine learning models, and how with that we are going to implement a better solution by using BPM patterns and start from a solution that is mostly manual to something much more robust and mature. This is how we are approaching agentic with our clients. So first step would be that if we introduce an AI agent in our processes in a BPM engine, the first thing that we are winning is full observability. Not just at the agent level, because we would be using, of course, some kind of framework that provides that traceability, but at the full end-to-end process level. And this is key for questions like EU AI Act or GDPR. By just putting the agent inside a business process, we are already winning all those capabilities. So imagine that the AI agent would be extracting that extra information, would use as a tool the machine learning models, and then it has two possible outputs. This is called an ad hoc sub-process, and this is a pattern used also in BPM engines. So we would have two possible outputs for the agent to confirm an underwriting decision or to request additional documentation to the customer in order to run another updated evaluation. Of course, everything that an agent decides have to be reviewed by a person because of GDPR. So this would be a send loan decision, but if you see here, we need to send this loan decision to be approved by a real human or expert, okay? So in the first step, we have won that visibility of the process. In the next step, what we will be doing is increasing the trust in results. And this is a pattern that seems quite logical, that is, okay, if I have one person doing one task, usually when we implement business processes, we have a reviewer of that task. So we implement usually the same pattern, but with agents. We have our evaluation agent, and then we will implement a review agent. The best pattern is to use another LLM, and the best thing is that usually when we are working with humans, we cannot access their chain of thought. We cannot access what were the premises that build up to reach those conclusions. So in this case, with agents, we can access all the chain of thought and all the tool calling of this previous agent and this reviewal agent will make that revision to be able to provide another opinion about if their recommendation was correct. Then here we have another BPM pattern that is an escalation event, and this what means is, imagine that we reach a bad state, an error state. Instead of crashing the application or the process with this escalation event, what we are doing is, I'm going to show you in the next one, is to add humans in the loop. So we are not losing all the context that has been generated and all the data that has been generated by this agent and by this other agent. And during the escalation event, we will, with all that context, pass the necessary information to a real expert, to an underwriter, to be able to adjust or review the decision. So this would be the next pattern. And another important pattern that we usually use is that, okay, what about strict business rules? Imagine that I am a 25-year-old boy that wants to have that credit and I work on my own and I earn less than 30K a year, for example. Maybe the bank has a rule that this cannot ever happen. Well, maybe this is a quantitative example, but imagine this with qualitative information that the agent might have extracted. So what we are doing here is to implement a rule engine table. Okay, this is a domain notation table. And the idea is to specify there the strict rules that we cannot miss. And with that, even the agent misses or hallucinates and provide a wrong underwriting decisions, we will be evaluating that decision against our actual business policies. So if it violates the credit policy, what we will do is to report that event. We will register that failure with our tech team. Okay, this is all based in real implementations, and the tech team will evaluate what did happen to the agent. So they can correct, they can adjust the agent, what was wrong, if it was the context, if it was the tooling. And finally, another pattern that we would like to show you that closes a little bit all of this is that usually we think on interacting directly with agents, so the human interacts with the agent. But what if we do it the other way around? What if we allow agents to have another possible output, that is this of requesting opinion of the expert? So in case that the agent considers that it cannot advance on its reasoning, it could request opinion to a senior underwriter, and when the opinion is received, we would run an updated evaluation for this agent, providing a new instance of it with new context and the agent with the new information. So this is some patterns that we usually apply with our business partners. And I think that the final thoughts are, okay, we can think about creating simple agents with N8N or with Codex or Claude or whatever, but on real business operations that are critical, the change from starting with just an agent on the business process to an actual more robust implementation of it or integration of the agents is an engineering problem. You have to know about the processes, and you have to know how usually business processes patterns work. So we want to give this overview from our real experience of how does we implement AI agents on production. So thank you very much, and I hope it was good. Yeah, okay.
For questions, we'll have questions at the end, so we can stay on track. It's like 10 minutes sort of debate go on and on and on. So we started a little bit late, so we'll go straight into the next one. Right.
Okay, great. Hello, everyone. It's a real pleasure to be here, and especially with the speakers who I have on stage, who I'll introduce. My name's Frank Williams. I work for a company called SRC. We're based up in Lincoln. We are a non-for-profit, and we work primarily in the defense space. We've, for the last year, been building a solution with Red Hat and IBM that we want to talk a little bit about today. It's very much focused on sovereignty and data governance and digital choice. And we're trying to build a platform that allows the data owner to retain ownership of their data and choice over their digital future. And on stage with me today, I have Daniel, who you've just met from Habber Tec, who's one of our partners with IBM in building the solution. But I also have Nigel Benwell and Gabrie from Red Hat, who are also partners of ours, where we've been building the solution in their lab, and are really, really excited to have them on stage. I'll just hand over, if you could do a quick intro before we launch into the first slide. Yeah, if that's okay.
Yeah.
So Nigel, yeah.
Hi, everybody. So as it's on the slide, I'm the Director for National Security and Defence in the UK for Red Hat. As you will probably all know, every conversation we have at the moment is about AI, it's about sovereignty, it's about security, it's about agency. Okay, and so it's really important for us. There's lots of decisions that you all have to make on a daily basis about what you do with your data, what you do to retain control, how you retain control in a financial aspect. That's what we're all about. And we look forward to having the conversations with you.
Yeah, thank you, Nigel. Vic.
My name's Gabrie. I look after the solution architecture team within the UK public sector. Not sure if everyone knows about Red Hat, but Red Hat's the largest globally the largest open source software provider in the world. And as Nigel said, we have lots of conversations about why sovereignty is important. I'm sure we'll dig into some of that in a bit.
Thanks, Vic. Yeah, and you all know Daniel. So let me just move on. So that's me. First slide here. So what we're here to talk about today is a product called WASP, which stands for the World All Source Platform. We see it as sort of a people's Palantir. It's an open source solution for aggregating data, extracting value from that data, and doing it in a way that retains agency and, most importantly, provenance and governance. So Daniel was talking earlier about scaling using agentic AI, using machine learning. But how do you do that in a way that allows you the confidence that you're not creating a lot of risk in implementing systems or solutions that might have regulatory oversight that you need to comply with down the road that you haven't considered, might have policy requirements or jurisdiction issues around that data. And we're trying to build a platform that shifts all of those decisions to the person that's actually running the workload, so they can make that choice ahead of running or making the architectural decisions or running the workloads before they get into the sort of problems that they would have if they haven't considered that stuff. So what we did about a year ago is we built we started building a POC, a proof of concept with IBM, using IBM funding to build this system using an open source stack and what's the next governance. One of the big issues that came up when we ran this event last year was the US Cloud Act. Amongst others, the EU AI Act is coming as well. There's GDPR, there are various other policies, but the US Cloud Act in particular was one that we were focused on because a lot of people didn't realize that it actually grants the US authority and jurisdiction over your data in spite of where the data actually sits. So residency doesn't actually mean sovereignty. So you can have data that sits, for instance, on an Azure server that's here in the UK or a AWS server that's in Europe. But it doesn't mean that the data owner has sovereignty over that data. The Cloud Act gives the US, in that instance, under that regulation, jurisdiction over that data. So we saw this as potentially an issue that we wanted to solve for. And it isn't just the US Cloud Act. There are other acts as well that have sometimes changing policies which are hard to manage.
like the EU AI Act, for instance, which starts in August of this year? And how do you create a framework and a platform that gives you oversight over what's going on regulatory-wise, governance-wise, while still gives you the ability to use frontier tooling and scale your AI and your ML? And that's what we're trying to solve here to do today. So we put this platform for two problems, one platform, right? It's the sovereignty problem and the governance problem and the scaling problem. That's what we're trying to solve together. System we built, sovereign by design, built on open standards, open source, right? Which is Red Hat, IBM have been huge proponents of that. As Vic said, Red Hat is the biggest supplier of open source software in the world. Also AI governance, watsonx governance, which is built on IBM Open Pages, is one of the biggest risk control platforms in the world, heavily used in financial services, already has strong credibility and provenance in that space. So it makes sense to take that across into AI governance going forward. We wanted to create a cross-domain solution that allows multiple sources, multiple data types to be ingested in one platform, aggregated at scale, governed at scale, and then scaled with frontier tooling. We wanted it to be dual use as well. So we have defense use cases that's our background, but we wanted to create a technology that could be applicable to financial services, to healthcare, to critical infrastructure, etc. So this is what we've built. Sovereign infrastructure, first of all, Red Hat OpenShift. Maybe Daniel, you could explain a little bit about the architecture that we built over in Red Hat.
So we have built this solution. We moved it from POC to MVP. And what we have done to provide that sovereign is, first of all, we started by using sovereign infrastructure. We deployed everything after installing a Red Hat OpenShift node, okay, in our cluster. And we have also relied on other partners like Cove, that maybe you can explain better after. But on top of this, we have been working on the development of several services that are based on IBM technology that can be installed on-prem. That is that of watsonx Data and IBM Knowledge Catalog. watsonx Data allow us to create a modern data lakehouse. Those are similar to some products that you might know, like Snowflake or Azure Databricks, but everything with open source technology. We are relying on Spark engines, on Presto engines for querying in a distributed way. And we are also relying, of course, on the power of OpenShift to deploy on-demand containers that are requested to launch data processing workloads. So everything, the data, the processing engines, the services run on-prem. They run on containers on the Red Hat OpenShift platform. And on top of that, we have built some backend systems that interact with the APIs that watsonx Data provides, with the APIs that OpenShift provides to be able to deploy those containers. So we have created a platform that have the power or the capacity that other big vendors have, but everything remains on your own infrastructure with your own tools. You can even extend easily the processing engines that you want. And it's really powerful for use cases where you want to have your data and your processing on your side. This is useful mainly for critical data, but we don't want to just stay there, because, of course, this platform can also connect to external data sources like S3 buckets with less critical information that we want to consume also to build data pipelines, to build data sets for our machine learning models. So we can merge all of that whilst maintaining all the information and all the processing in our infrastructure that is really critical for the US Cloud Act. So this is kind of the architecture. And if you need some more detail, I would be really happy to talk with you.
Thanks, Danny. And perhaps I could just hand over to Vic from Red Hat to talk a little bit about the Red Hat solution and what you have in the sovereign space.
Yeah, so as Danny mentioned, we've got a platform, right? It's a standardized open source platform that you can pretty much run anywhere, whether it's on hyperscalers, whether it's on your own infrastructure that you own yourself, or whether it's at the edge, right? And that standardization is really key. And we're seeing that as AI is growing, the capabilities for AI and the requirements for AI is growing, the skills are not catching up, right? There's always this problem with skills. Do we have the right skills and the capability to be able to run at the speed we'd like to run at? What we enable is that standardization. So wherever you'll need to run your workload, you can make a real decision about where it needs to be, because it doesn't always need to be on-prem. It could be okay in the cloud. So you can make an active decision about where it needs to be and still have the skill sets that allows you to move as fast as you can.
Yeah, thanks, Rick. Yeah. And then just moving on. So we deployed the solution at the Red Hat lab in Morrisville over the last 2 weeks, and we've been doing testing there. And we've been successful in being able to deploy the solution at scale with governance, with everything that we wanted to build when we started talking about this 6 months ago. But what I wanted to talk a little bit about now was the ability to scale beyond the cluster. So we use a company called Cove, which has a software-defined memory solution, which allows you inside of a data center to be able to connect memory pools so that you can use them as if they were inside the cluster. And this was a really important notion for us, because most of the machine learning problems that we were trying to solve were memory bound rather than CPU bound. And we faced an issue, especially with scaling around the costing, where if you wanted to add memory, you also had to add CPUs. And this became very expensive. Not that memory isn't expensive, but when you have to add CPUs and compute nodes as well, it became prohibitive. And in the data center, there was what we call gray area compute, so memory that wasn't being used in other servers, and also compute that wasn't being used. Using OpenShift, we can federate out to those nodes, but also using Cove, we could federate out to using memory outside of the cluster. And we were able to demonstrate that we could do this with no loss in latency, which sounds really amazing and crazy in a way that you can actually access memory in a box that's outside of the box that you're running it on and do it quicker than you would inside that box. But we were able to demonstrate that because of the architecture and using fiber interconnects, this was actually possible. And the key finding was that with a lab setup, we were able to increase the throughput by 5 times by using memory outside of the cluster, which was a really, really amazing finding, which means that for an existing footprint of compute, you could run 5 times the amount that you would have otherwise been able to run through that system by using spare memory outside of that cluster. We went from 768 gigs to just about 2 terabytes, and we were able to classify about 50 different types of, in our world, emitters, which are RF types of signatures a second. So that was a key finding, and it was a real success that we worked with Red Hat, and we're looking to build upon that going forward. And that's pretty much the presentation. But yeah, I'd be happy to take any questions that you guys might have about the sovereignty question and scaling. Nothing? There's one there. Oh, just wait a second, there's a mic coming. Yeah.
A lot of US clouds, for example, they comply with the local government policy. Like why we need Red Hat to implement Red Hat as well for the data.
Well, yeah. Do you want to take that?
I'll go back to the original point, and it's really about the definition of sovereignty. Because what you've got to, in sovereignty you can really sum up as agency. That's your freedom, your choice, and your control. Now that can be over whether it's the best tech, where it needs to sit, who can access it, or even your exit choices. I will never, you won't hear me in any conversation going, oh, if you go with proprietary stacks or proprietary capabilities, you're going to have a problem. What I'll always ask you is, though, in every decision you've made, have you got agency? Can you leave when you want to without any, being screwed over in that space? Do you have control over who can access it legally, by company, by geography? Do you have that access? And if the answer is no, that still might be okay, because these are sovereignty decisions, okay? But if you want to have that agency and that choice and that freedom and that control over perhaps your finances, or the company what you thought was great in 2026 no longer feels quite as great in 2029, okay? Then if you need that, that is why you build on open source. Vic can tell you as to why Red Hat capabilities in the open source, why we're the world leaders in that. Does that answer it? I mean, it might have been a leading question, but this is about giving you choice and freedom, ultimately.
Yeah, thank you.
Thank you. We've just been talking about the data silos earlier on when Daniel was touching base, and the word cloud was mentioned many times. So how does that work technically? So if I have my data in S3 or blob storage in Azure or SQL or whatever you want to call it, how can I make that data sovereign? It's already on the cloud. How can I invite it? Eventually, I will need a compute. I will need a storage. I will need a lot of features to be able to basically have that sovereignty. I just feel I'm either missing something or.
Can I take that one? Is that okay?
Please.
Yeah. The first part of that. So that's a great question, right? So a lot of companies, a lot of institutions have already invested in the cloud solution. They've been doing it for years. And it might be difficult to get that data out of the cloud. How do you manage that? Well, there's a few ways. First of all, you can encrypt the data that's on the cloud and keep the keys on-prem, right? So yeah, the provider can deny you access to the data, but they can't read the data, right? So that's one potential solution. Second potential solution is, well, if I stand up a framework alongside that cloud provider, and when I put data into that framework, I also put it into data I care about that I want to keep sovereign into my own framework, right? Now I have choice still over the data that's in my framework, which is open source. So to take an example, with, let's say you're putting data into Azure or into S3 buckets, right? And you're concerned about, I don't know, US Cloud Act on that data, right? Well, okay, that's fine. You can encrypt that data, but you might get denied access to it. So you stand up an OpenShift on-prem or hybrid cluster. It'd have to be on-prem unless you're using a UK cloud provider. And you also stand that data up there, and then you have digital agency over that data around the choices you make with that data, the value you extract from that data, metadata you create, ontology you create around that data. But you still have the ability to use the other cloud, but you understand what the choices are around using each, right? And what we're trying to do as WASP is surface those concerns ahead of you running the workload. So it's like, okay, I want to go put data somewhere. So it'll ask you, well, what kind of requirements do you have of that data? And then based upon those requirements, it will spin the workload up where it makes most sense to put that workload. So if you don't want it like under the jurisdiction of the Cloud Act, it will spin the workload up and store the workload on a UK cloud or an on-prem cloud, right, or an on-prem set of servers that that's outside of that jurisdiction. Or is it an EU AI Act workload, right? So then there's regulation around that you have to be concerned about. Well, where's the best place to go and put that compute and put that storage? Does that make sense?
I'm just going to add a little bit to that. So for me, the question around so I talk to the UK government, different departments quite a bit, and they are heavily in the hyperscalers, right? So one of the questions that we get asked is, well, we're already in the hyperscaler. So what is sovereign? Why does AI need to be sovereign, right? When all of our data is sitting in Azure or AWS or Google or wherever, right? For me, the question is about just being aware of what that means, right? So we did a roundtable 6 months ago with different government departments, and they didn't even know what the US Cloud Act was. They had no idea what it was, how it affected them, what it does. Interestingly, you can go to like Azure, and they actually publish the amount of requests that have come in from the government, for the US government. So that some of that data is out there. But it's about just being aware and making a conscious decision. As Nigel was saying, like that control is, not everything needs to be in your own data center. But if you just think about what is the right place for that data, should our NHS data be sitting on a US data center or not, right? That's quite a hot topic at the moment. But those are the questions you need to ask. Like, is this whatever I'm building, wherever my data sits, should it be somewhere I can control, or is it okay to sit in a hyperscaler where I have limited control?
Thank you. And just to add, since you mentioned one of the Azure, which is in UK South, does that mean the US Cloud Act still apply while the data in UK South and UK West? Yeah.
Yep.
All right. Okay. Thank you.
Can I just ask, do we have any UK cloud ownership at all that doesn't have anything to do with any of the US companies?
They're starting to come up. So there's a whole bunch of neoscalers that are starting to be created, and some exist that we partner with. One of the beauties of open source software is that actually you are future-proof for that. So as new UK-based, UK sovereign cloud providers start cropping up, like they are able to use open source software, and actually that, we are partnering with them and NVIDIA, so all that capability kind of exists.
Likewise, there's a number of them across EMEA in the European space, in the European Union in particular, where they are, competing with those hyperscalers who are currently in the NHS and that sort of area. And increasingly, I think in Europe, it's becoming a big driver as well. It's all about politics at the moment, I guess, in that space. But you know why we're going that route.
Yeah.
Taking the sort of
taking the sort of quixotic nature of political sovereignty out of the question, in terms of we could have the EU come up with a similar act, or somewhere else like China, and then use the data in the same way the US currently is. For something like Cove, where you're saying you're using the memory clusters and then you're outsourcing and then getting an output from that, would that have a similar issue regarding the sovereignty in that you're trying to access memory from, say, a separate cloud or a separate memory cluster and then use the Cove software in order to output a solution?
Well, it depends where you're running it. So you can run Cove on-prem, hybrid, or in the cloud. But by running it through WASP, it will give you the agency over the choice, right? So if you submit a workload and you're sensitive to US Cloud Act, it will give you a solution that reflects that, right? So it won't use Cove on a US set of rails, right? It will use Cove if it's available on your hybrid or your on-prem solution. Or perhaps it will use a US set of rails, but it will tell you that you need to encrypt that data and put that into your workflow to enable you to satisfy the requirement that you don't want to be under the jurisdiction of that particular act.
So it's acting as a troubleshooting system.
Not so much troubleshooting. It's just surfacing those regulatory governance, FinOps kinds of questions ahead of you putting the workload in the system, right? So using FinOps as an example, you're not going to get the bill for your data scientists run, or you're going to get the call from your legal, your data governance department that you've created all of this overhead and this cost after the workload has run through the system and it's already too late to change it. So, we use this term, is the juice worth the squeeze? We're trying to shift that left in the process of running workloads. So the framework is aware of these things and presents you a solution that's defined for the workload that you want to run with all of those concerns.
Does it circumvent the issue where if you have a set of data owned or held within a particular sovereignty that you can't access that, even though you may need that in order to produce your output. So, for example, with the NHS, it's being used by, say, Palantir. We don't want it to be used by Palantir, but if they're the ones that hold on to that data because we've completely migrated it to Palantir's system, how does something like Cove allow you to facilitate you not to use that or choose to get similar data from the NHS directly?
It wouldn't be Cove, it would be WASP, and WASP will say, okay, you want to run this workload, you're going to take data off US rails. Here's a governance report of what you're going to incur by running this workload, right? So here's, so you're aware, it's coming back to what Vic said, before you run the workload, it makes you aware of what the ramifications of running that workload are. FinOps, governance, regulatory, right? All of that, in our view, needs to be known by the operator ahead of hitting go, right? Right. That's what we're trying to do. Yeah. Any other questions? Oh, one over here. We've got 5 minutes left.
My question is that how does the country itself use AI to protect itself from, let's say, external cyber attacks from like different organizations or even internal attacks?
That's a good question, and that's really, I think, hold that question for the panel later, because we've got HashiCorp on there, and they have a great product called Vault and Boundary, which will answer that. Our system incorporates some of that technology, and as does Red Hat, but it's not really part of the core offering of WASP, what we're talking about here today. But save it for the last session. Yeah, cool.
One more.
Yes.
Thanks for that. Really interesting. I was just wondering what the vision is for where you're going to take this next.
What's the vision? Okay. Well, there's probably a few answers to that, depending on. So let me just say where we'd like to take it next. And when we're an R&D company, we try and create innovation that then gets scaled. Where we would like to take this next is to a data marketplace. So one of the challenges that we see in adoption is that there's a trust issue around the framework, which is why we've gone with open source as much as possible. Data owners are reluctant and have been reluctant. I'll take the NHS as an example. Sovereign owners of data can include like a practice, right? It has patients. They've been reluctant to adopt like Palantir, the federated patient record, because they don't trust the platform is going to give them the ability to control their data downstream and potentially monetize that data. It's an asset after all. So where we see this going is an open source framework using blockchain, Hyperledger, which is another IBM initiative, to be able to create a marketplace for all of the data. So there's an incentive for data owners to want to use the platform, to be able to share their data, to use it for machine learning, et cetera, be able to have the confidence that if they put the data in the platform, they retain ownership and governance of that data downstream and the ability to commercialize it. That's our vision, but I guess Red Hat, I'll hand it to you.
Yeah,
guys.
I mean, from our perspective, look, we're a large open source company, right? The UK government, so Minister for AI, Kanishka Narayan, has set out his vision for the UK to be the leading open source AI country. And so we want to promote the open source use. For us, that is that is why we exist. The ability for anyone to contribute to our, to the upstream projects, like that is a great thing. It democratizes software and it democratizes AI. That's where we'd like to be, that's where we think we should be going with that.
Does that answer your question? Yeah, it does. Okay. Is that it? Anyone else? I think we're good, right?
If we can just draw a line there.
Yeah.
And if there are any questions, there's plenty of
Oh, good. Well, Richard.